Hey guys, it's AxiomaticUncertainty here, and today I'm going to be showing you some work on a simple new project of mine. So the first thing I'd like to note is that this project is not close to complete. I had to take a long break for the start of the school year so as to transition more smoothly into that whole process. However, I am ready to come back and start making videos again, detailing my endeavors with regards to machine learning, and hopefully illuminating some of these concepts for you. So, today's video is just talking about the beginnings of this project and the ideas for where it may go. As you can see, this is just some simple code running OpenCV. You can see that imported up here. And what we're doing is we are using OpenCV in order to determine the location of a face within a given image, and then putting a highlight around that. So pretty standard stuff. A lot of this code can be recycled from their example documentation, and then I've added a few changes such as this one, and some stuff with regards to the way we're doing all this stuff. With the prints, a lot of abuse of this ternary operator. Sorry about that, but also not. Yeah, we're just displaying this modified version of the image. So, enough of that. I'll now show you some of this stuff coming out of this. It's not too bad. It's certainly okay. So, webcam's loading up. There we go. So, you can see there's a pretty bad amount of variation here. However, if I move backward a bit, it should become a bit more stable. There we go. So, you can see the camera will consistently follow me across the screen until I exit at either side. So, yeah, it's pretty nice. It's very, very stable. And if I just move a bit closer, I can talk about some things that are actually rather interesting about this whole thing. So, first off, if you can see, we have a nice little readout here, the sizes of each individual box. So my webcam here is a 480p quality. So that's our resolution being printed at the bottom. And then we also have a little scrolling, if you can see it once it's paused. This is just a little output of the, so this is the image information. It's in the shape category in CV2. And basically this would be the number of channels, the height, and the width. And, using this, we can just sort of get a nice readout for everything that's happening. You can see here, this also ties into things because troubleshooting it was a bit interesting. Obviously, we have to convert this to an integer, so we parse it in order to get indexes. Obviously, we can't use doubles or floats for that, so we've converted them to integer values. Additionally, we're using, as I said, the ternary operator in order to clamp the image to fit this resolution for this webcam, such that if I move upward, we don't start, coming out and creating issues. And then you can also see if this, if I put my hand in front of it, it just pauses. So, it's a very nice way of running things. Yeah, see, so even if I stay still, it's going to have a little bit of an issue there. But yeah, that is the beginning phase. Now, moving on, we're going to be talking about how we're going to do this. Now, what is this project would be the most important first step to describing how we'll approach, completing it. Well, this project is going to be a way of creating an automatic locking system for a door, which uses a database of images collected from users who've been sampled and categorized as being individuals who can access said room, and it'll unlock itself upon getting one of those images within its webcam feed. So it's essentially like face identification for a smartphone, except used on a door. And how are we going to do this? Well, you may be saying to yourself, oh, this is very complex. How are you going to get this to work? Obviously, there are a lot of, specifics about this. There can be changes in lighting, changes in distance, changes in size. Everything is variable when it comes to these kinds of systems, especially since, people, even clothing, change on a daily basis. So, again, how are we going to do this? Well, the way we can set up this classification system is that we can take these individual layers here, right? This is called the Inception Model. It's created by Google. You can see I have it up here, Google Inception Network. And the way this works is that we take in, a large amount of data, and we can just sample it in order to extract features and then classify it. And basically, this is a principle of transfer learning, but if we cut off these individual classification layers here, we can take the robust high-level features that it's generated and create our own flexible classification model by tagging on classifier layers, dense layers in this case, and then training those layers to better suit our needs based upon our data. However, we don't lose any of these features that it's trained on, and we don't lose the power of this network. So we can harness all of that without, any major strain on our system. So it's very interesting. You should definitely look into how transfer learning works a bit further if you want to know more about it. However, for the sake of this tutorial or more update video, I guess, we're not going to go into detail with any of that. So, what is the project? We've already covered that. We've covered how we're going to get there, I think, to some degree. Obviously, we'll use SQL databases to store the images of people or just file folders on a machine we could run, like a Raspberry Pi connected to and interfacing with a computer of some kind, I guess, maybe. I don't know how we're going to get the hardware side working yet. Typically, I'd use an Arduino, but obviously, this is going to require, more computing power than that. So, yeah. Another interesting side note and, idea is that we could potentially take a given screen capture or image from the program. So, for instance, let's just pause it here and take a look at this. So, you can see the frame is frozen. It appears to be crashing or something. Okay, let me just resume playing this thing. So, you can see the frame, right? Now, if I freeze on a given frame, like this, what we can do is we can take this individual frame and add it to our database. And if we add the frames to the database of our, that's being stored on the machine, then over time we can build up a larger set of images of that specific person or of people who are allowed into this, given program. So, the idea is that we'd be, allowing them into this room. The individuals who are granted access are, essentially instances of files, and each folder contains the images of that individual. And over time, this thing can automatically add more images, which can be manually sorted by a human, and then, over time, again, as time elapses, it will get better and better at, categorizing people because it'll have more examples of different situations, with which to, from which to check for, similarity scores. So, essentially, if the first image is in poor lighting or something like that, or later they're in poor lighting, and then it's confirmed by a human, then in the future when they're in poor lighting, it'll be more confident because it has an example in poor lighting that can be counted, and factored into the average of, their example class. It's kind of weird, but basically the idea is that you take an individual's instance and you'd come up with an average similarity score for that person with the given image. And, upon further analysis, could then narrow things down and keep doing more searches on the remaining people in order to finally come to a conclusion as per the actual individual, being presented before the camera. And, that's essentially the idea for this project. So again, I will be posting more updates on this as it comes out. We have a database that we're using, the labeled faces in the wild dataset. The images are quite zoomed out, but they're centered on the individuals, and that's what we tried to do here. So we have about the same zoom as a given image here, and I'd say I did a pretty good job at that. So, you know, this shouldn't be too bad. This project should be manageable, and I'm hoping that once it's finished I can upload it to my GitHub, as with, you know, many of the other projects that I've done. So yeah, that's gonna be it. Bye guys.